As we get started today, we're going to look at practice exercise 74 in your practice exercise booklets. Before we do, though, I want to review with you how to use scientific notation to write really big numbers a lot quicker. Now, to be fair, a lot of what you'll do in science is rounding numbers off. So you might look at this and say 32,000 or 32,127,000. Well, that's approximately 32 million, right? But you don't want to have to write 32 million because all those zeros, it just gets old, right? So the key to scientific notation would be to take the decimal, which I don't see the decimal. Where is it, class? That's at the end, right? It's at the very end. Move the decimal so that there's only one digit in front of it. Well, as we read from left to right, the first digit we see is the 3. I'm going to put it right after the 3. So now instead of 32 million, it's 3.2. And then once you hit straight zeros, you just stop. You don't want to write those zeros. That's the whole point, is getting out of the zeros. And then we're going to say times 10 to, well, what power do we use? Well, however many zeros. This would be first power, second power, third power, fourth power, fifth, sixth, seventh, because there were 7 places I moved the decimal. So we'd say this is 3.2 times 10 to the 7th power. We could have done it even before we rounded anything off. The decimal's still at the end. I still have to move it so it comes after the 3. But this time it's not just 3.2, Genesis, it's 3.2. But it's still times 10 to the, well, I still moved it 7 places, didn't I? Times 10 to the 7th power. It just isn't rounded off as neatly here. But it's the same process. Do you remember this from Algebra 1, possibly Algebra 2, those who've had it? Science classes, for instance. It works the same way with small numbers. For instance, if I had 0.0000364 or something like that. Well, I don't want to write all these zeros at the beginning. So we can move the decimal back so there are how many digits before the decimal, class? 1. Once again, it's going to happen to come after a 3 because 3 is the first digit. So 3 point, class, 645. But when I write my answer this time, you're still counting how many places the decimal moved. Back 1, back 2, back 3, back 4, back 5. How do I show back 5? Times 10 to the negative 5th power. Because it's not times 10, 100,000, or 10, 100,000, 10,000, 20, and so forth, right? It's tenths, hundredths, thousandths, and so forth, right? So hence the negative exponent because of the reciprocal. Do you remember this now? You're going to be practicing with this on exercise 74. Wait till everyone has their booklets to get started, please. So practice exercise 74. You're at the top of page 21, and you may begin. Questions? All right. And you have page 67, 147. And you go there. Ooh. I'll call you both one. If you both got them perfect, I'll give you both candy. go to put your pencils away and take out a pen. Pencils away, take out a pen, and exchange with the other person in your row. Exchange with the other person in your row. If you would, in pen, sign your name next to where it says exercise 75. There at the bottom of exercise 74. Sign your name as greater in pen next to where it says exercise 75. There at the bottom of exercise 74. Again, pencils should be off your desks. And it's going to be 8 points each. 8 points each. Going across the top row first, so you got 5.8 times 10 to the 6th. For the next one, 8.69 times 10 to the 8th. For the next one, 5.67 times 10 to the negative 5th. And for the last one on that row, 7.3 times 10 cubed. Next row going across, 4.73 times 10 to the negative 2nd. 5.89 times 10 to the 6th. 7.68 times 10 to the 5th. 5.74 times 10 to the negative 4th. Bottom row, 3.2 times 10 to the 4th. 7, or 7 point, times 10 to the negative 5th. 5.764 times 10 squared. And 1.3 times 10 to the negative 3rd. All right, there are 8 points each, so figure the total number wrong, times 8, subtract from 100, put the score next to where it says exercise 74. Put the score next to where it says exercise 74. Question, yes ma'am?
What was the last one on the first row?
7.3 times 10 to the 3rd, or times 10 cubed. Yes ma'am?
So you're saying that's a negative 7?
It would be wrong, yes, because that's going the wrong direction. It makes a very different answer, right? So, you know, how much thrust do we need on this rocket? So much. But they get a negative on there. It doesn't get enough thrust. Or, you know, how much power should we give it? Just a tiny bit, and we blow up a computer. So no, the negative makes a huge difference. So yes, that would make it wrong. All right, once you got the score on there, return to the owner. And let's see, Quentin and Chris tied for first. Did either of you gentlemen get a 100?
I literally wrote times 10 to the 10th on the last one, on the first row.
That's sad. So no, Quentin? No. All right. So Audrey, you were next. Did you get 100? All right.
Jamie got one too.
All right. Well, she was third though, so she was ahead of Jamie. I called you to a tie because it literally looked like y'all put your pencils down at the exact same moment. All right. Any other hundreds? Just not as fast as Audrey. All right, Jamie. How about 92s? Just missed one. All right. 84s just missed a couple. Questions at all before we hand these back in? All right. Let me go and collect those from you then. And if you did the extra credit, have it out. Even if you didn't do the extra credit, make sure you have your books open to page 182 as we'll go over the extra credit. How many did attempt the extra credit last night? Jamie, good. Audrey, good. Anyone else besides Jamie and Audrey attempt the extra credit? All right, just you two ladies. All right, so let's go and take a look at it. Page 182. Have your compass and your straight edge at the ready. And number 21 from the homework, or from the extra credit, page 182, what were we attempting to construct here, Audrey? All right, so we're trying to construct, and the rest of you do this with me now on your paper, an equilateral triangle given the sum of the three sides. So we're not given A, B, and C. We're given A plus B plus C. So draw a nice long line, maybe, I don't know, 4 inches or so, 5 inches or so. And call this line A plus B plus C. This is all three sides of the equilateral triangle mushed together. Well, that don't exactly help. If I knew each side as we come to our sketch, A, B, C, if I know all of them, I'm going to be good, right? But knowing the sum doesn't help. at least not at first. The key to this was figuring out, how do I discover how big A, B, and C are? Audrey?
I took my compass and opened it up, second out. And marked out 3 places on the map.
So you said this is A, this is B, and this is C? But that would mean that this is A plus B plus C. But it's supposed to be the whole thing. So I guess we should have opened it a little bit more, right? And there's A, there's B, and there's, oh, that's too big. Okay, so we close it just a little bit, right? And there's got to be a better way, right, Audrey? So, no, Audrey didn't get it. Let's see, Jamie, did you do it the way Audrey did, or did you find another way to figure out how big A, B, and C have to be?
I did a different way.
Okay, what did you do?
I did I can't remember what number, but I did construction to divide into 3.
Oh, yeah, you remember, I think it's construction 11, I think, where you divide a line into any number of equal segments, draw that line coming off at an angle, mark off any number of segments, in this case 3, connect it up, make some parallels, and that's what we should have done. So you said that's what you did, and that allowed you to find the measure of A or B or C. And then, yes, so, all right, good job on that, Jamie. All right, the rest of you, and Audrey, good job trying it at least, right? Putting some thought into it. You knew we needed A, B, and C. At least we put that much thought in. Let's all go ahead and finish the construction now. Draw a long line coming off at an angle. Remember, here you will essentially do what Audrey had suggested you do up here, but we're going to do it on this line. Open it some reasonable amount. Mark off an A, a B, and a C. We're out of 1, 2, and 3. We're going to number these points. And remember, scribble off that extra portion of the line. We don't need that, don't want that, it's just in the way. Go and connect the 3 point up to the free end of A plus B plus C. And then once you've done this, remember, we're going to need to open the compass up a little less than it had been before. Make a nice arc through both sides of this angle. Then come through this side and make a sweeping arc. Then come through here, make that same sweeping arc. Measure how big the arc is and mark off that arc, that distance, if you will, on the other 2 arcs. When you connect the dots, you should have a series of parallels to cut off equal segments on one transversal. Therefore, we cut off equal segments on any other transversal. And so apparently, this right here is A, this right here is B, and this right here is C. Now, you're not done with the construction yet. This was a means of getting A, B, and C. However, do I need to measure each of them? They should all be exactly the same, shouldn't they? If you wanted to check, I suppose, you could see, all right, is my A the same size as my B, the same size as my C? Yes, they're all the same size. But once you've got that measurement of how big A or B or C is, because they're all the same, right, divided equally, how do I turn this measurement, Jamie, into a triangle?
Well, you make a big long line.
Good. All of this is preliminary. We haven't even started the construction yet. We start with a big long line. So, Jamie, we start with our big long line, and we pick A.
One of the segments and measure on the...
Okay, well, I would say start with the starting point, right? And you can pick anywhere, but there's not a reason not to just pick the first end point, right? So then you said measure one of the segments, A, B, or C, doesn't matter which. I've got the measurement right here.
And measure on the line as a base.
Good, and you can call it A or B or C, really doesn't matter. If you wanted to scribble off extra, you certainly could. This gives me a second point, and I'll just call it B to match the sketch that I drew. Then what?
Put the point on the starting point on the left on the line, and do a big arc.
Good. I don't know where A is going to be, right? But I do know the other one end of A is going to be down here, and the other end is going to be somewhere along this arc, this given distance from this given point. a circle, right? With the given point, this endpoint is center, and this given distance is radius. Somewhere along this arc is where A is going to fall. What do I do for the other?
The same thing.
Right, but now I'm going to go to this endpoint, because C has got to start here, and somewhere along this arc. Well, where the two loci intersect is where my triangle will be formed. And apparently, when you connect the dots down here and down here, you've constructed a triangle given the sum of all three sides. And that's what we should have had for the extra credit. Audrey, does that make sense now? All right, seem a lot more sensible than what we had tried. All right, and then the rest of you didn't take time to do the extra credit, but does it make sense now how we would have done it? Any questions on the extra credit now? All right, well, you're right there on page 182. Let's take a look at number 22 next. And Chris, what are we going to try to construct in number 22?
An equilateral triangle.
Okay.
Given the altitude.
That's it? Wow. All right, so we're going to construct an equilateral triangle.
Well, we know that there's also equal sides, so it's not hard.
Right, okay, but given the altitude, right? And then Chris makes a good point. On the surface, it's like, that's all I'm given is just one thing. Well, there's a fact that we know, and that's that all of the sides are going to be equal. So go ahead and draw a line segment. I wouldn't make it more than 1.5 inches, maybe. Okay, somewhere between 1 inch, 1.5 inches. Don't make it super long. And let's call it H for altitude. That's the only thing that I'm given. But there are facts that we know, right? So once we've got our information copied down, we always class start with a sketch. Sketch a quick equilateral triangle. And in the sketch, label your altitude. What do I know about this picture? Well, Chris already told us, I know all three sides class are going to be equal. What else do I know about this picture? Okay, I do also know all the angles are going to be equal. In fact, not only do I know they're going to be equal, I know they're all going to be exactly how big, class? 60 degrees. Well, the whole angle at the top is going to be 60.
So 30 and 30.
Are you sure it's 30 and 30? How do I know it? Do I know that
No,
it
it's
bisects?
not. No, we don't know that for a fact because...
Well, yes, I do.
Every triangle has to add up to 180, though.
Well, it does.
And an equilateral triangle, the altitude bisects the base.
Not just an equilateral triangle, in an isosceles triangle in general, but equilateral is part of that. The altitude is always going to, you said bisect the base?
Or bisect.
It is going to bisect the base, but it's also going to bisect the
Angle.
vertex angle. So I do know I'll have exactly 30 degrees on either side. What else do I know about my picture?
The other angle that you haven't filled out yet is 90-degree angle, so you have a right triangle.
Right, the altitude is going to be perpendicular, so I'm going to have perpendiculars here. Not only that, but Quentin, coming back to something you accidentally said, but I think it could be helpful, this is going to be the perpendicular bisector, because in an equilateral triangle, which is isosceles, in any isosceles triangle, the altitude bisects the base as well. So I've got a perpendicular bisector here. Okay, that's a lot to go on.
I feel like there's a lot of methods you can use to figure this one out.
I'm trying to think of various, I've got one method in mind that I want to use. I'm trying to think if there's another method, but let's go and get cracking.
Big long line.
Big long line. All right.
Sounds all right.
We're not staring at a blank chalkboard now. Well, we have a sketch before, I guess. Ooh, now here's the problem. On the surface, I'd be like, hey, let's get a perpendicular bisector. But I know this point, right, could be, for instance, here, but I don't know where the other end is, right? This whole line probably isn't my base, right? So I can't just make a perpendicular bisector right here.
Make that
Why
line.
don't you just copy the altitude?
Copy the altitude here? Does the altitude go like this in my picture?
Like, measure it and then flip it vertically.
Make that line.
Oh, okay, so you say make the big long line a vertical line.
I'm saying.
I'm open to that.
I'm saying take the compass, measure the line that you made as the altitude, put the point of the compass, and then flip it vertically and draw the line vertically, like that.
So you're saying make the altitude up here.
I don't know where the altitude is.
Yeah, I don't really know where the altitude is. Now here's the thought. Here's the thought, class. We could rotate the picture, right? And if we rotated the picture and made this altitude, which is my only line I actually know, I could make the altitude go this way. It would look a little funny, but there's my altitude, right? Yeah, I could do that. Or
Altitude base.
I could flip the big long line. Why not make the starting point at the top? Does that make sense? After all, I know the altitude comes down off the top, don't I? So why not make instead of a long horizontal line, let's make a long vertical line, and let's make our starting point be at the top of the triangle. Now, what method clearly suggests itself?
I have an idea.
Let's go with this. Let's go with this. What do I do now? Should be really screaming in your face obvious.
Altitude.
Copy the altitude. The altitude attaches to the top. Measure the altitude, mark it off. Now, this is not one of the vertices of the triangle, but this point right here is that point right there. Do we see it? That's got to be helpful somewhat. Now what? I now have 2 points I can work off of. I can either keep working off the yellow top or the white bottom. Following our blueprint. What attaches to the yellow top?
The points.
Altitude.
Would be altitude, but I've already copied that. Anything else attached to the yellow top? 30-degree angles, right? What attaches to the white bottom?
9 degree.
Perpendicular.
Drop.
Let's put a perpendicular. Yeah. Put the point down here, open it up, make a little mark. Make a little mark. Open it wider. Make a little mark. Make a little mark. Now make sure you go through both sides, because our sketch doesn't only have a perpendicular on one side of the altitude, right? So I guess technically then, since all of this now becomes just kind of extra, I've used it, but it was extra before. Now here's the only kicker. I don't know either of these points, right? I do know that however far over we go on one side, we have to go the same distance on the other side, right? However far over here is how far over there. But I can't just make up a random distance, right? Because if I make up a little distance, okay, that's not going to be equilateral. How do I know how big of a distance to make, Chris?
Well, you can figure out the 60-degree angle, can't you, by, say, since that's a 90, can't you cut it in half? Bisect it, gives you 45, then bisect that gives you 15, and then add it together gives you 50.
Whoa, bisect 45 gives you 15? That'd be 22 and a half, wouldn't it? But I like his thought. You remember that day we did a whole lot of bisect, crazy stuff? Okay.
60.
I'm sorry?
Well, no, we don't know 60. We don't have 60.
We don't have a 60.
Well, if you take the 180 angle and cut it in 3 parts.
How do we cut an angle in 3 parts?
Well, we did one how much?
No, we cut a line in 3 parts, not an angle in 3 parts. So Chris brings this point up. His thought is, okay, if I can't really do anything at these vertices, right? Because I don't know where they are. But I do know where this point is. If I can find a way to construct a 30, so let me say it again. You remember that day we constructed a whole lot of different sized angles. Did we ever make a 30?
Yes. Yes, we did.
How did we do it?
Made 60 and then bisect.
We made a 60, we did. Now, how did we make a 60 though?
We had to have a 30.
Nope. No, we didn't have a 30 to make a 60. We started with a 60, then we made the 30.
180.
Nope. How did we make that 60?
Bisect to 120.
How did we make a 120? I mean, you realize if we could figure out how to make a 60, we'd be golden, wouldn't we? All of you should already have a 60.
Wait.
Kendall?
There's already a 60 in the triangle because it's equilateral.
Well, I mean, it's not a perfect 60. There's 60s shown in my sketch, but I don't have any 60s over here.
Extend a line on the triangle? Well,
We do have a 60.
Where?
If you take from the point of the line, you connect it down to the other side, the angle that's formed will be 60.
Just any line? Like which line?
No, from the endpoints. The endpoint of that top line to the endpoint of the...
Oh, no, I just drew this line at random. This is just a random line.
So that won't give you a 60.
It wouldn't give me a 60 necessarily.
Can you do an arc? Is there something you can do an arc?
All right, let me refresh your memory. If you want to make a 60, you need an equilateral triangle. Now, I'm trying to construct a very specific equilateral triangle that has exactly this altitude, right? But if I just wanted to make any old equilateral triangle, I could draw any old line. I could open my compass any old length, maybe that exact length. I could make a little mark up here, and I could make a little mark here, and I would have any old equilateral triangle. Now, it's not the one I ultimately want to construct, but if I can get any old equilateral triangle class,
You can get a 60.
then I have any
60.
60-degree angle. And if I have a 60, I can make a 30 by doing what? Make another make an equilateral triangle. All of you technically already have one because we just constructed an equilateral triangle a moment ago. Remember at the start of the class when we went over the extra credit? All of you should have an equilateral triangle already, except for Ethan who just came in late. So the rest of you all have an equilateral triangle anyway. Bisect any of the 3 angles to get yourself a 30. But yeah, you can make a 30 anytime, just have to make a quick equilateral triangle. Bisect it, and you've got a pair of 30s. Now, then we've got our 30s. What do I do with the 30s?
Well, you copy the angle.
Copy them over, construction 3. So you've got your 30, open the compass up, different than maybe we did before, okay? So maybe like this, and make an arc on your 30. Come to the top and realize you're gonna have to put a 30 on both sides. So I'd make a nice, if you can do it without losing where your compass is supposed to be, make a nice big arc so that there's some on either side. Then measure across the 30. Mark 30 off on one side, 30 off on the other side. And when you connect those lines down, you'll have the equilateral triangle with that exact altitude. A little bit of outside the box thinking here, right? We make it work. We come up with a way. We strategize. We copy what we know. We know we've got an altitude. We know that means it's going to be perpendicular. Now what? Well, if only we had a 30. Find a way to get a 30. And Chris was on the right track. We thought we get 45, we get 22 and a half. We're right, but if we can start with a 60, we can get a 30 and so forth. Question?
Could you have also done this if you started with the altitude as a base?
Yes, but the picture would have been turned sideways. So you would have ended up with a picture that looks like...
Right. I mean, but it doesn't matter what the picture looks like.
Right, as long as it's an actual equilateral triangle, it doesn't matter if it looks a little goofy. I just wanted to make it match the sketch, which is why I showed a vertical line, but it could have worked the exact same process with a horizontal
So
line.
it would have been the same speed.
Yep.
Okay.
All right, question Genesis.
What did you do on the angle that's across from the 60?
Angle across from the 60?
So that one, that triangle.
Well, this right here is a 60. All I do is I bisected. So open the compass, make little marks, and drew this bisector. So now I have 30 here and 30 there.
And then what did you have for that?
All right, so then I opened the compass a different amount, right? So I just opened a little bit further, and I made an arc across just the 30 now. And so then I carried that arc out over here on both sides. Then I measured across just this 30 arc, marked it off here and there. Now I've got a 60 at the top, therefore 60s at the base, and there's my equilateral triangle. Good question. Good. Any other questions? All right, getting a feel for the kind of outside the box thinking we're doing here in this section. Let's do a few more. Drop down to the bottom of the page now, and let's change gears. We've been doing a lot of triangles. Right triangles, isosceles triangles, even a couple equilateral triangles. Let's move on. Construction of quadrilaterals. Let's do number 2. Number 2 in the bottom section of page 182. What are we constructing now? Ethan?
A square and given diagonal.
A diagonal?
A diagonal.
All right, so we're constructing a square given a diagonal. So construct square given a diagonal. So that's not a lot, but draw your one line. Make it, I don't know, inch and a half-ish, maybe 2 inches at the most. And I'll label it D for diagonal. D for diagonal. That's it. All right, so let's draw our, not yet, sketch. Let's draw a sketch of a square. I think it doesn't have to be perfect, but it helps if it looks close. Now, which diagonal do we want to say we've got?
It doesn't matter.
Ah, there's an important fact, right? It doesn't matter which diagonal, class, because in a square, the diagonals are equal. I could draw this one, or really I could draw them both. They're both diagonals, right? They're equal to each other. That's important. What else do I know about these diagonals?
They bisect each other.
They bisect each other. So half the diagonal will be here, half there, right? What else do I know about the diagonals of a square?
Bisect the angles.
They will bisect these angles, that's true. What else do I know?
They form equilateral triangle. No.
They do not.
So they're equal, bisect. Oh, they're angle bisectors.
That's what Ethan said. They'll bisect each of these angles here. Yeah.
They're perpendicular to each other?
They're perpendicular to each other.
I almost said that.
Right triangles.
So we know we've got perpendiculars, we know we've got bisectors, and we know they're going to be equal to each other. So here I'm going to have half a diagonal, half a diagonal, half a diagonal, and half a diagonal. Right? I think we might have enough to go off of. Now, our first step in actually doing the construction, of course, class, is to draw our big long line. But notice, I think I would rather draw my big long line either going slanty like this or slanty like that. Because the only line I can go off of is a diagonal, right? Now, is it wrong to do it horizontal? No, but if I want to make it match the sketch, let's draw a line that kind of slanties upward like so. Or you could have done it downward slanty. Okay, I'm going to do an upward slant because things are always looking up. Now, we can either make this my starting point, or we could make this the starting point. And, Quentin? Bottom? All right, so we're going to start down here at the bottom corner. That's where we usually start anyway. So let's say that down here is this point. You realize I need to ultimately know these 3 points, and then I'll be able to just connect the dots and I've got my square, right? What might we do first? Yeah, we see that I could easily get this point here if I just measure the diagonal and mark it off. And boom, I now know this point. All right, so that's 2 out of 4. I got 2 more points to go. All right, what next? Somebody other than Quentin?
Saying how to do a perpendicular.
Even better, a perpendicular bisector, right? Because it's not just perpendicular; it's perpendicular bisectors of each other. So yeah, let's make perpendicular bisectors now. Compass more than half, arc above and below, other point, below, above, and connect los datos. They say in Espanol. Just kidding, they don't really say that in Espanol. All right, and now I've got this dot. Well, this isn't one of my big 4, but it is a dot worth noting, right? I now know the this dot, and that dot.
We know we have equal angles because there's all right angles now.
Right, I've got 4 right angles. I could label those if I wanted to.
So, if all the diagonals are equal, just take the half and measure it off on the side.
Ah, okay, so you're saying we need half diagonals everywhere, right? Well, here is a half diagonal. And this, of course, is also a half diagonal. So you're saying if I were to measure off a half diagonal here and a half diagonal here, that I would now have these other 2 points. Is that what you're saying, Chris?
Yes.
In other words, I now have all 4 points.
And
So
just connect the
to finish my square class,
dots. Connect the dots.
connect the dots.
I'm too smart.
Now again, this required you to remember that the diagonals were equal. It required you to remember that the diagonals are perpendicular, that the diagonals bisect each other. If you didn't remember all those facts, you couldn't do this construction. Do you see how essentially we're reviewing everything we've learned little bits at a time in picture format? And there's our square. Questions on this? Makes sense? All right, let's move on to another one. Let's go to number 3. Numero 3. Let's see. Genesis, what are we constructing this time?
Construct a rectangle having given a diagonal and angle within the diagonal.
Hey, let me make sure I heard that right. A diagonal and an angle between the diagonals. Is that right?
The angle.
The angle between the diagonals. Okay, so constructing a rectangle given a diagonal and the angle between the diagonals. Now, what may help us here is to actually start with a sketch before we even draw all of this stuff. Picture this with me. I'm going to go ahead and draw it. You may want to draw this as well on your paper. This is what we're trying to make, right? A rectangle. And I've got a diagonal. Which diagonal, Genesis? I'll let you pick. The one going up or the one going down? The one going up, okay? But I know this diagonal, for instance, but obviously if I were to draw the other diagonal as well, these 2 diagonals make angles with each other. They will make acute angles or obtuse angles, right? It's really up to you which one you want to go with. Genesis, we could either draw ourselves the acute angle that's formed or the obtuse angle. Really doesn't matter which. Acute. All right, so we're going to be given this diagonal and that angle. Make sense? So draw yourself a line. Make it maybe a couple inches long. Somewhere between 2 and 3 inches long maybe. And call it D for diagonal. And then let's also draw ourselves an acute angle. And this is going to be the angle between the diagonals. Again, on quizzes or tests, this line and this angle, it would already be on there for you. You wouldn't have to come up with it. I would provide it to you. Again, we've already kind of drawn the sketch, right? I've got my diagonal labeled here. I've got my angle that I'm given here. What else do I know about a rectangle? Chris, you've helped me a lot. Let's go to Ethan. You've been pretty much worthless. Ethan, why don't you... I just like
Not the
picking.
first one.
Ethan, help us out. What else do we know about our picture besides this diagonal and this angle?
I believe the diagonals bisect the angles.
They don't necessarily bisect. These 2 angles will not be equal necessarily to each other.
The left side and the right side are equal.
This side and this side are equal? Okay, yes, these 2 sides are going to be equal. What else?
And the top and bottom are equal.
Yeah, no, opposite sides of my figure are going to be equal to each other. Now, I don't know any of the sides, but I might be able to figure it out, right? So that could be useful, knowing that sides are equal. Let's go to Audrey. Has been quiet back there. Audrey, what else do I know about my figure?
The diagonals are equal.
Oh, I do. So really, I don't know one diagonal. I really know both of my diagonals, don't I? What else do I know, Audrey? Oh, the diagonals are going to bisect each other. So kind of like the last construction, I've got half diagonals all over the place, right? But they're not perpendicular this time, right? Square they would be. Here they make a funny little angle between them. But otherwise it looks a lot like maybe what we were doing earlier. Anything else I know that anyone feel is significant or important to mention?
The opposite angles are equal.
Right, in fact, the opposite angles are not only equal, but all the angles here are going to be class.
Equal. Or no,
They will be equal, but they'll be
90 degrees.
right angles, correct? 90-degree angles. So I'm going to have right angles everywhere. Okay, so that might be of help to us as well. Let's see. I think I've labeled just about everything. Thought through. Let me say that again. Thought through all the things I know before I even get started. Now it's time to start. So let's draw our big long line. Now, how do you want to draw the big long line, Genesis? Let's make the big long line slanty. Now, I don't know exactly at what angle to make it, but let's make it slanty-ish like we did before. And Genesis, I assume we'd like to just start at the bottom corner again. Okay? So let's say that this point here is my starting point. Now be careful. Do not construct a perpendicular, because this side is not perpendicular to the diagonal. It's perpendicular here. Does that make sense? So don't go making a perpendicular yet. If I knew where this line went, and I don't, then I'd be able to make a perpendicular off of it, but I don't know that yet. Kendall, what do you think we ought to do?
I'm not sure.
Okay. There we go.
And you put the point of the compass on the starting point and you mark it off on the line.
All right, because if nothing else, Kendall, then, this gives us this opposite corner up here. Now I've got two of my vertices. Again, do you see the emphasis is always on find that other point, find the key points in the picture. So I don't know this point yet. I don't know this point yet. And I would say there's one more really key point to know. Yeah, the very middle would be another good point to know. Thoughts on finding any of those three remaining important points? Quentin?
Bisect that diagonal, find the center point.
All right, so Quentin's thought is let's bisect this diagonal. Let's find where the center point is. So let's go ahead and do that. I think that would be helpful. How many thinking the same thing, by the way? That is the exact right thought to be having right about now. Now, I will throw this thought out there. When you get your midpoint, that's really all I care about. I don't really want a perpendicular line, do I? So I would either very lightly draw it, or maybe draw it as a dotted line or something, or if you draw it, maybe go back and erase it or something. I'm going to draw it really lightly here. Because I really don't care about this line. I only care about this point here. I needed to know where that point was, and I now do. The rest of the line is absolutely worthless to me, but that point isn't. All right, Chris, thoughts?
Well, we have the center point.
Mhm.
We have both points of one diagonal, right?
Right, so I've got all three of these. I just don't know these
That's
two
the
points.
we do know, because the diagonals are equal.
They are equal to each other, right?
And they bisect,
Right.
so measure half and then flip it vertical again.
So kind of like we did before, I'll measure this and I mark it there and mark it there, and now these are my other 2 points?
Yes.
Uh-oh, I'm getting some concerned looks. Thoughts, class?
Be a square. That would be a square.
It would be a square, and this would then be the other diagonal, wouldn't it?
But aren't
But
they?
this isn't the other diagonal. The other diagonal is not perpendicular. The other diagonal makes this angle there, doesn't it? Now, it's not a problem necessarily to get this measurement, but I don't know exactly where the point is. In fact, I know it's not here. I know along this locus, somewhere along here is where this point's going to fall. And somewhere along here is where this point's going to fall. Do you see that? So it's not a bad thing to take that half diagonal measurement, but I don't know exactly where. I just know somewhere along here, somewhere along there. So how do I find exactly where? Chris wants to redeem
I have a
himself.
question. Can we inscribe a rectangle into a circle?
Huh?
Can we make that a circle?
You could, I suppose, inscribe a rectangle.
Because then we would have the stuff. Everything would be equal.
The hard part would be you'd have to have not just these opposite points, you'd have to have at least one other point to know. For instance, you could just make the whole circle, I suppose. I mean, really, truly, you've got this measurement. You could put a circle just all the way around there, right? Which, again, this is not quite perfect, but
well, we have right angles now, don't we?
it's clearly not drawn to scale. But you get the idea. Like, you could put a circle around this, right? But so far, the only line I know is that one, which is a diameter, right?
Any angle drawn in that would be a right angle, though.
It would, but it's not just any rectangle with this diagonal. It specifically has to have a specific angle between the diagonals, which means what do we really need to do right about now, class? Put this angle on the picture somewhere, right? That's got to be our next step. We've got to have that angle somewhere. So let's copy it. Where? Genesis? Where? Where is it in my picture? On my sketch. Remember, we're following the blueprint. Where is my angle in the sketch?
Right there.
Okay, where is right there? Describe where we have it in the sketch. It's at the center and it's below the diagonal, right? So where should I put the point of my compass on the construction? And I should mark down below the diagonal. Just like it is here, right, Genesis? Here it's at the center below the diagonal. Here I'm going to go at the center below the diagonal, right? We're making it match, in a sense, our blueprint, our sketch. So make that arc. Now, if you happen to still have it open this circular radius length, that's okay. Measure off on the arc now exactly how big the arc is and drop it down here. And of course, stay with me for just another minute. We'll connect these dots. Now, when I connect the dots, I don't have a rectangle still, but I do know something.
Measure off half the diagonal.
I actually already measured off half the diagonal, and that would be right here, wouldn't it? So I now know that point.
It's a radius?
But yeah, of the circle, sure.
So that line would equal the other lines.
So what would I do to finish? I still don't have a rectangle.
Copy it backwards.
Yeah, don't just draw the line this way. Draw the line both ways, right? So you hit the circle on the other side also. So now I know this point as well. Does that make sense? And now, how do I get my rectangle?
Connect the dots.
Connect the dots. These two dots connect straight down. These two dots connect straight over. These two dots down. And these two dots over. And I've got the rectangles, the only rectangle that has this exact diagonal length and this exact angle between those diagonals. Questions on this construction? All right, you're going to do 3 constructions for homework this evening. You're going to do page 182 at the bottom, exercise 3.34, numbers 1, 5, and 8. Page 182 at the bottom of the page, exercise 3.34, numbers 1, 5, and 8. We have a test coming up on Wednesday. That'll be in 4 more lessons. Test coming up Wednesday. In 4 more lessons, it is only constructions and locus problems. It's the whole test, constructions and locus problems. All right, so that coming up Wednesday. Have a wonderful rest of your day, and you are dismissed.